right? So if you had to find g of f of negative 5, well, you know, we've already found 2 slides ago, we found g of f of x, right? G of f of x was x minus 2 squared. So again, how would I evaluate g of f of negative 5 if I know that that's what g of f of x is? Is plug the negative 5 in the place of x, right? So I'm going to put this negative 5 in the place of the x. So it's negative 5 minus 2 squared, which is negative 7 squared, which is 49. So if you've already found the composition function, then you could plug in and find it. But that's not always the way people do these problems, right? This is instead the way that you would see it. Even in the example, this is an example in the book, example 3. They do it both ways. They do it this way that we just did, but they also do it like this. If we wanted to find g of f of negative 5, that is g of f of negative 5, right? Well, how do we find f of negative 5? Here's f of x. What's f of negative 5? Negative 5 minus 2, right? F of negative 5 equals negative 5 minus 2, which is negative 7. So this is like saying g of negative 7. Okay, then how do you find g of negative 7 if g of x equals x squared? You express x as negative 7, so that's negative 7 squared equals 49. And it's the same. It has to be the same thing. But they take it like a two-step process. Right? You plug in the negative 5 into the f. Right? That's a domain kind of thing. And then you calculate the value. You get negative 7. Right? That's a range. But then that plugs into the g like an x value, like a domain. And then you get the answer. So the output of one function is the input of the next function. So let's say you'll see them both ways. The thing is that this book tends to underdo this stuff, but this is the stuff you'll be asked to do all the time. In math classes, you always have to find the g of f of x and the f of g of x, not just turn it into a number problem, but to actually be able to do it with the x's involved.